Imagine looking at your energy bill and seeing nothing. Not a reduction, not a rebate, nothing. A zero where the total should be every single month, every single season, year after year. That is not a dream scenario from some future technology that has not been invented yet. That is an ordinary Tuesday for an Amish household in Holmes County, Ohio. What you're about to understand is the precise system they use to heat, cool, and maintain their homes without sending a single dollar to a utility company. Not solar panels, not wind turbines, not anything being advertised on any home improvement channel you have ever watched. This is older than all of it, simpler than all of it, and so fundamentally effective that multiple states have quietly introduced building code requirements specifically designed to make sure you cannot replicate it without also being forced to buy the systems they are trying to replace. Stay with me through the end of this, because the final technique I'm going to share with you has never appeared in a single modern home building guide, homesteading manual, or construction resource I have ever encountered. When I finally understood why it had been omitted, everything about the modern energy industry suddenly made complete sense. The average American household sends $2,400 every year to utility companies. That is $24,000 over a decade. $120,000 over 50 years of home ownership. Money that leaves your account on a schedule so predictable and so normalized that most people have stopped questioning it entirely. It is just the cost of living in a house. It is just what electricity and heating cost. Except that it is not inevitable. It never was. And the utility companies that have spent tens of millions of dollars lobbying legislators, funding regulatory bodies, and shaping building code requirements at the state level understand that better than anyone. They understand it because the alternative, the system that keeps Amish families in Lancaster County and Holmes County warm in January and cool in July without paying anyone anything, was already perfected 4 centuries ago. And the only reason you do not live in one is that your ignorance of it is worth $2,400 a year to someone else. Let me start at the very beginning, at the foundation of everything, at the single decision that separates a home that manages its own energy from a home that hemorrhages money to a utility company every month for its entire lifespan. Before an Amish master builder places a single stake in the ground, before he draws a single line on a plan, he stands on the land and watches where the sun moves. He watches it in the morning and at noon and in the late afternoon. He watches it in summer when it tracks high and in winter when it hangs low on the southern horizon. And then he orients the house. Every Amish home in Holmes County, Ohio, has its longest wall facing within 10 degrees of true south. Not approximately south, not generally south. Within 10 degrees, every single one. This is called passive solar orientation. And it is not a modern green building concept. It is ancient physics that the Amish preserved while the rest of the construction industry abandoned it in favor of building faster and facing the street. Here is what that orientation actually does. A south-facing wall in the northern hemisphere receives direct sunlight from the moment the sun clears the horizon in the morning until it sets in the evening during the winter months, precisely when heating is needed most. In the same house in July, when the sun is high overhead rather than low on the southern horizon, that same south-facing wall sits almost entirely in shade. The house collects solar heat in winter and deflects it in summer through nothing but geometry. No moving parts, no seasonal adjustment, no technology required, beyond knowing which direction south is and building accordingly. Penn State Extension has studied traditional building orientation systematically, and their published data confirms what the Amish determined through 400 years of empirical practice. Correct solar orientation alone reduces a home's heating load by 30 to 40% before any other element of the system is added. 30 to 40% of your heating bill eliminated permanently by the direction no house faces. Most American homes are built facing whatever direction the street runs because that is what the development layout requires, and because reorienting costs the developer 20 minutes of planning time that they do not want to spend. You pay for that decision for the next 30 years. But orientation is only the first layer. The second layer is where the Amish system begins to pull away from anything a modern home improvement store will ever show you. Walk around an Amish home and pay attention to the windows. They are not distributed evenly around the building the way windows are placed in a standard suburban house. The south wall carries large windows, multiple of them, with deep sills that extend 12 to 16 inches into the room. The north wall has almost no windows at all, perhaps one small opening per room positioned high near the ceiling. The east and west walls have moderate glazing, carefully sized and placed. This pattern is not aesthetic preference or cultural tradition. It is a calculated thermal engine designed to do specific thermodynamic work. Those large south-facing windows function as solar collectors during daylight hours, drawing radiant energy directly into the living space and converting it to heat. The deep sills are not decorative. They create a thermal buffer zone that moderates convective air movement near the glass, slowing the loss of collected heat back through the window surface at night. A standard modern window has a sill 3 inches wide. An Amish windowsill is wide enough to sit on. There is a precise engineering reason for that difference, and it has to do with how warm and cold air move near a glazed surface, something the old builders understood through observation and that modern construction simply discarded in the transition to fast, standardized framing systems that prioritize build speed over thermal performance. Now here is where most explanations of passive solar design stop, and where most people assume the system breaks down. They hear about south-facing orientation and solar windows, and immediately ask the obvious question, what about summer? What about August in Ohio when the temperature is 94 degrees and the humidity makes the air feel like warm soup? This is where the cross-ventilation system enters, and this is the component that genuinely surprised me the first time I saw it fully explained. Amish homes are designed around a specific internal geometry that generates natural airflow through a principle called the stack effect. The physics is straightforward once you see it. Cool air is denser and heavier than warm air. Warm air rises. If you place low intake openings on the shaded north side of the house, where the coolest exterior air accumulates along the wall surface, and position high exhaust openings on the south wall and upper sections of the structure, the warm interior air rises continuously and escapes through the high openings, pulling cool north side air in through the low intakes behind it. The house ventilates itself, continuously, automatically, passively. No fan motor, no compressor, no electrical connection of any kind. An Amish family I visited in Lancaster County had a farmhouse built in 1887 that relied entirely on the system for summer cooling. The husband told me that the second floor bedrooms stayed 8 to 12 degrees cooler than the outside temperature through July and August, with no mechanical intervention whatsoever. I stood in those rooms and checked the thermometer on the wall myself. He was not embellishing. The house was noticeably, measurably, comfortably cooler than the air outside in summer, with no moving parts, no electricity, and no monthly bill. This is also where the building code situation becomes impossible to ignore, and genuinely difficult to interpret charitably. In multiple states, including sections of Pennsylvania, Ohio, Indiana, and a growing number of others, current residential building codes require mechanical ventilation systems in new construction, forced air fans. If you submit architectural plans for a new home that designates natural cross-ventilation as the primary cooling mechanism, you will be required by the code inspector to add mechanical systems regardless. The natural system is not technically prohibited. It is simply rendered irrelevant by a mandatory requirement to install the alternative. You pay for the mechanical system whether you intend to use it or not. Cornell's building science program has documented this regulatory pattern in published academic work. The language in those papers is appropriately neutral. The practical consequence for anyone trying to build a naturally cooled home is not neutral at all. Utility companies have been funding advocacy for these specific code requirements since the 1970s. I will leave the interpretation of that timing to you. But the element of this system that stopped me completely, the piece I found myself thinking about for weeks after I first encountered it, is the thermal mass. And to understand why it matters so much, you first need to understand something about heat that most people were never taught. Heat is not simply a gas that fills a space like air fills a balloon. Heat can be stored physically, held inside solid material the way water is held in a reservoir, and released gradually over time as the surrounding temperature drops. Adobe, stone, brick, rammed earth, and dense clay all have high thermal mass. They absorb heat slowly over hours and release it slowly over the following hours. An Amish home built with thick stone walls does not maintain its interior temperature simply because it is insulated against heat loss. It maintains its temperature because the walls themselves are a heat storage system. The walls are the battery. A standard modern wall built from 2x4 framing with fiberglass batt insulation has essentially zero thermal mass. It is an adequate thermal barrier, meaning it slows the transfer of heat through the wall assembly, but it stores nothing at all. The moment outdoor temperatures drop in the evening, a framed wall stops contributing to interior warmth. A stone wall 18 inches thick that spent the afternoon absorbing solar heat through south-facing windows is still radiating that stored heat back into the room at 2 in the morning. The wall is working for you through the night without any fuel input. This principle is 4 centuries old. The builders of the American Southwest mastered it in Adobe. The early European settlers who built in stone understood it instinctively. The Amish preserved it deliberately. Modern production construction abandoned it around 1950 in exchange for walls that go up faster, cost less to frame, and guarantee that the homeowner will run a furnace every night from October through April for the rest of the home's functional life. Now we reach the heating system itself, and this is where I need to be straightforward with you, because when I first encountered a full description of how this works, my instinct was to assume someone was exaggerating for effect. The Amish thermal mass stove, known in the German-speaking tradition that most Amish communities descend from as a Kachelofen, operates on a principle that is almost the precise opposite of how a modern wood stove functions. Understanding the difference explains everything. A conventional wood stove burns slowly, incompletely, and continuously to maintain room temperature. It requires feeding every few hours. It produces significant creosote accumulation in the flue because the combustion temperature is too low to fully combust the volatile gases in the wood smoke. It generates heat that rises rapidly to the ceiling and escapes before the room mass can absorb it effectively. It is, in thermodynamic terms, a relatively inefficient way to convert wood into useful warmth. A masonry heater operates on an entirely different logic. You load the firebox with 2 or 3 large pieces of dense hardwood and light a fire that burns intensely for 1 to 2 hours at extremely high temperature, then goes out completely. That is the entire fuel input for the day. Done. But the firebox and the surrounding structure of brick, stone, and dense clay, which in a traditional masonry heater weighs between 3,000 and 5,000 pounds, has now absorbed an enormous quantity of thermal energy that mass radiates heat slowly and evenly into the living space for the following 18 to 24 hours as it gradually cools. The surface temperature of the heater never becomes dangerously hot. It stays warm enough to be comfortable against bare skin, warm enough that children lean against it and animals sleep beside it, but never hot enough to cause burns. The heat delivery is gentle, even, and constant in a way that no forced air furnace cycling on and off can replicate. The combustion in a properly designed masonry heater reaches temperatures above 1,800 degrees Fahrenheit, hot enough that the burn is nearly complete and creosote formation is minimal. Auburn University's Forestry and Wood Products Research Program has published efficiency measurements for masonry heaters that place them at 80 to 90% thermal efficiency, compared to 60 to 70% for the best modern EPA-certified wood stoves currently on the market. A family in a properly oriented, thermally massive Amish home in Ohio burns 3 to 4 cords of wood across an entire winter. Wood they harvest from their own land. Fuel that costs them nothing beyond the labor of cutting and splitting. Their heating bill is zero. Their heating bill has been zero for as long as anyone in the community can remember. The average American household spends $400 on heating in a year, every year, without interruption, for the entire time they own the house. The question that deserves to be asked directly is why any of this feels like obscure or specialized information. It should not feel that way at all. None of these techniques are patented. None of them require exotic or expensive materials. None of them require engineering credentials or specialized construction equipment. A household with basic carpentry ability, access to stone or dense masonry materials, and a piece of land with a south-facing aspect could implement every element of this system from scratch. The reason it feels like forgotten knowledge is not accidental. The moment passive solar orientation, thermal mass construction, natural cross-ventilation, and masonry heating become genuinely mainstream knowledge, a substantial fraction of residential energy demand simply disappears. The utility companies understand that arithmetic precisely. The building products industry understands it. The regulatory and lobbying infrastructure that both industries fund and maintain understands it. The obscurity is not a side effect. It is the product. Now, I want to give you the single piece of this system that I have never encountered in any modern construction manual, any passive solar design guide, any homesteading resource, or any video in this space. I found it in a 1903 United States Department of Agriculture survey of Amish and Mennonite settlements in eastern Ohio, buried in a section on traditional agricultural building practices that I suspect has been read by approximately nobody in the past several decades. It concerns the thermal management of the floor. Almost every discussion of passive solar design and Amish construction techniques focuses on walls, windows, and the heating system. The floor receives almost no attention. But in the older Holmes County settlements documented in that 1903 survey, the earthen or stone floor of the main living area was constructed over a network of clay channels, roughly 4 to 6 inches in diameter, buried 6 to 8 inches below the finished floor surface. These channels were connected to a south-facing inlet opening positioned near the base of the exterior wall at ground level. During clear winter days, cold exterior air entered through this inlet and traveled through the buried channels before emerging into the living space. As it moved through those underground passages, it exchanged heat with the surrounding earth, which maintains a nearly constant temperature of approximately 55 degrees Fahrenheit at that depth, regardless of what is happening at the surface above. The air arrived in the living space pre-warmed by passive geothermal exchange. No pump, no fan, no electricity, no moving components of any kind. Pressure differential and natural convection drove the airflow. The 1903 survey referred to this system as a ground tempering channel. Roman builders of the first century used a functionally similar principle in the hypocaust systems that heated their public buildings and bath complexes. The Amish families in Holmes County who used it had no name for the engineering principle behind it. They called it simply the floor breath. And according to the measurements recorded in that survey, it added 8 to 12 degrees of warmth to incoming winter air before it made contact with the living space. In a home that was already benefiting from passive solar orientation, thermally massive walls, deep south-facing windows, and a masonry heater burning 2 or 3 pieces of wood per day, the floor breath was the final layer of a system so thoroughly integrated that the house itself became the heating appliance. The survey documented interior temperatures of 60 to 65 degrees Fahrenheit maintained through Ohio winters, with total fuel consumption of essentially nothing beyond the wood the family cut from their own property. 60 to 65 degrees through an Ohio winter. 2 or 3 logs per day is the only external energy input. No bill arriving in the mail on the first of the month. No rate increase letter from a utility company. No dependence on a grid that fails in ice storms and floods and heat events. No exposure to the policy decisions of energy corporations that have no accountability to the families they serve, and every financial incentive to charge as much as the regulatory environment will permit. I have been sitting with those numbers for a long time, not because they are surprising in some abstract intellectual sense, but because of what they reveal about the choices that were made on behalf of American homeowners over the past century. The shift from thermally integrated stone construction to fast-framed wood construction. The introduction of mandatory mechanical ventilation requirements that make naturally ventilated homes financially impractical to permit. The displacement of masonry heating knowledge by forced air furnace systems that require a utility connection and a monthly payment to function. None of these transitions happened because the old system stopped working. The 1887 farmhouse in Lancaster County is still working. The floor breath channels documented in 1903 are still a valid engineering approach today. These transitions happened because the new systems generated revenue in a way that the old systems did not. You cannot bill someone monthly for the direction their house faces. You cannot charge a subscription for stack effect ventilation. You cannot meter the heat released by a stone wall that spent the afternoon in the sun. But you absolutely can charge $2,400 per year, every year, indefinitely, to someone whose home was built without these things and who has no practical alternative. The Amish did not develop these techniques as a philosophical statement about self-sufficiency or cultural rejection of modernity. They preserve them because they work, because they produce comfortable homes without ongoing cost, and because every dollar not sent to a utility company is a dollar that stays inside the community and serves the family that earned it. That is not ideology, that is arithmetic, and the arithmetic has not changed. If you have ever stood in a cold kitchen in February holding an energy bill that felt less like a statement of services rendered and more like a consequence of having no other option, you now know that there was always another option. The Amish did not discover a secret. They simply never forgot what was already known. The house that heats itself, the wall that stores warmth through the night, the floor that breathes cold air in and delivers warm air out, the fire that burns for 2 hours and heats a home for 24. None of it was hidden. It was just never in anyone's financial interest to remind you it existed.